The topic of the day is we're going to extend our field theory and talk about this cool, deep connection between electricity and magnetism. Spoiling it, giving away, what we're going to eventually get to is you can't actually have one without the other. If you've got electricity, that electricity triggers magnetism, and if you've got magnetism, we can use that magnetism to trigger electricity. Before we get to the actual, like the meat of this, the physics of this though, I got a couple little background things to go through. I'm going to chunk the video so it's not too huge all at once. Okay, first thing, as we start this new topic, this electromagnetism, we're going to have to draw these vector fields, but in 3 dimensions. That's going to be tricky when we're working on 2-dimensional computer screens and 2-dimensional paper. There is a little trick to it. I'm going to teach you the trick. First, really simple, we're going to backtrack. If I needed you to draw a vector pointing to the right, it wouldn't be hard. You would just draw an arrow pointing to the right. Conceptually, what we're imagining is like an archery arrow pointed to the right. That's where the arrow to the right, that's kind of the connection. We're drawing what we see of the arrow. So we see an arrow pointing to the right. We don't usually draw the tail feathers, but they would be back there. Similarly, quite simple, if it's a vector pointing to the left, we would draw an arrow pointing to the left. The logic is if we could see this arrow, our archery arrow, head of the arrows over there, tail feathers would be back there. Kind of like that. I don't know if tail feathers is the right word. That's what I called them growing up, but that's probably an old word. Cruising right along, another easy one. If we talked about a vector pointing towards the top of the page, sometimes we call that up. And literally, we're just going to draw an arrow that's pointing up because our archery arrow, this is what it kind of looks like. Last kind of easy one, if it was pointing down or to the bottom of the page, we would just draw an arrow pointing down. Our archery arrow is now this way. Okay, the question is, what if, instead of pointing left, right, or up or down, what if that vector is pointing straight at your eyeballs, straight at you? Or sometimes we say, oops, I did it backwards, straight at you, which sometimes we say is out of the page. Or what if it was pointing away from you or straight into the page? Let's start with how I typed it, the first one first. What would it look like if you shot an archery arrow and it was flying away from you? How could we draw that? And then the next one we'll do, what if an archery arrow was shot straight at you? That's a little bit creepy, so maybe it was shot at a camera, some sort of special effect in a movie. What would it look like if an archery arrow was coming right at you? How could we draw that? That's the trick we're going to use to draw vectors in 3D. The accepted answers are, if you've got a vector pointing straight away from you, again, we're going to imagine it like an archery arrow. If the archery arrow is flying away from you, all you would kind of see are those tail feathers. So to draw that, we're literally going to draw an X and put a circle around it. This over here represents how we're going to draw a vector that's pointed away from you when we have to draw on 2-dimensional paper. So vectors pointing away, we're going to draw as an X. When we get rolling, we're going to talk about like a current pointing away from you, or an electric field, or a magnetic field pointing away from you. But any vector that's pointing away from you, we could draw as an X. So maybe you're doing some sort of work with displacements, and you say like a person walks 20 meters away from you. If you needed to draw that, we could just draw it as an arrow, or we could draw that away from you as an X to show that it's pointing away from you. It's tough to show how long those X's are, so maybe not the best example, but any vector that's away from you, we're going to draw as an X. Similarly, any vector that's pointing straight towards you, so imagine we've got an archery arrow shot at a camera for cool special effects in a movie. When it's flying straight at you, all you see is the tip of the arrow. So since you only see the tip, that sharp point, we're literally going to draw it as a dot with a circle around it. That's how we're going to tackle 3D vectors. A circled X represents a vector that's pointed away from you, and a circled dot represents a vector that's pointed towards you.